This is the first part of lesson 12.3 and 12.5 on pyramids and cones. This is actually the lesson 12.3 part, the surface area part, and then the volume will be in another recording. So this lesson is going to be about finding surface area of pyramids and cones. So first of all, a pyramid is this figure that you see right here. A polyhedron in which the base is a polygon and the lateral faces are triangles. With a common vertex. So this point up here is called the vertex of the pyramid, and that's different. This pyramid is different than a prism because the lateral faces will be triangles since they all meet at a single point at the vertex rather than being rectangles where there's two bases. There's only one base that's a polygon. It does have some common features of a prism, though. The intersection of two lateral faces is a lateral edge. Oops. And the intersection of the base and a lateral face is called a base edge. So same thing as with a prism. And then the height or altitude of the pyramid is the perpendicular distance between the base and the vertex. So the height is that distance right there. Now, if the pyramid is regular, that means that its polygonal base is a regular polygon, and the height will hit the center of that regular polygon. Remember that the center of a polygon is the point that would be the center of a circle if the circle were circumscribed around the regular polygon there, so around the base. So it basically means it's not slanted, it's straight up from the base. The vertex is straight up at the top. So this is perpendicular. The height there is perpendicular, making your vertex directly above the center of the polygon. Okay, now the pyramid has something, a regular pyramid has something that a prism did not. The slant height of a regular pyramid is the altitude of any lateral face. And again, the lateral faces are triangles. And there's a reason that we want to have something called the slant height. So the slant height is this segment right here. It's going to be the altitude of each one of those triangular faces. The reason that we need the slant height is because when you go to do the area of one of those triangles, so this face right here, for example, when you go to the area of that face, you're going to be doing 1/2 base height, and the base would be the base edge length, but the height of the triangle is going to be the slant height. So you'll do 1/2 base times height on each of the triangles, and the height of the triangle is actually the slant height of the pyramid. Okay, slant height is something that only exists in a regular pyramid. So you don't talk about slant height for any other kind of pyramids, just for regular pyramids. Something to note down here. Okay, and then a circular cone or just a cone is a solid that has a base that's a circle and a vertex that is not in the same plane as the base. Okay, so here's a picture of a cone, and this one's a right cone. This one down here is an oblique cone. That's the same terms that you had before. So a right cone is straight up and down, an oblique cone is tilted. Back up to slant height for a second. Slant height, the letter L, lowercase l cursive, is often used to refer to the slant height. I don't know why L, but that's just what we use. So L refers to the slant height of the pyramid, and we'll use h to refer to the normal height. Let me use red for that. The regular height of the pyramid, we're going to use h. So I want you to notice something here. On a pyramid, and this is also true on a cone, on a regular pyramid and on a cone, there is a right triangle that kind of stands up inside of there. So it's comprised of the height of the pyramid, the slant height of the pyramid, and then this little segment down here is something special. What is it? Well, it will be the apothem of the regular polygon, so of the base. Okay, now there is also going to be a triangle that you could draw. I'm going to switch colors here. Let me make it pink. There's also a triangle that you could draw, stands up inside, that looks like this. So depending on what you're given, that one's also perpendicular. That would be the height. So the one over here, let me mark this, would be the height, the slant height, and the apothem for that triangle. Okay, and then the one on this side that I'm drawing, then there would be a whole bunch of these different triangles. This one would be comprised of the height, the lateral edge, which doesn't really have a label, so I'm just going to write lateral edge. And then what is this thing? Well, that's a radius of this part down here is a radius of the regular polygon, because it's a radius of the circle that could be circumscribed around it. So just kind of keep in mind that depending on what you're given for the problem, as we get into a little bit more complex problems, we'll be sometimes having to use the Pythagorean theorem to figure out one of those missing parts when you're given certain information. Okay, back to cones. So a cone is just like a pyramid, except that it has a base that's a circle. Now again, it's not actually a pyramid because the base is not a polygon, but it acts just like a pyramid. So just like before, we're going to use the same thing that we did before. The formulas for pyramids will apply to cones also. Okay, so a right cone has a height that meets the base at its center, and then an oblique cone does not. So again, it'll look like it's tilted. Lateral surface of a cone is, we're going to do the lateral surface area just like we did with prisms, and just like we'll do with pyramids. And you should understand what the lateral surface is. It's described there as consists of all the segments that connect the vertex with points on the base edge. So it's all of these segments put together to form the surface. But most people would understand what that means to just say, like, if you were going to think of that as an ice cream cone, it's the outside surface of the actual sugar cone, and not including the inside of it, and not including any kind of base. So the lateral surface area, we're just going to use the curved part on the, or that goes around this way, not including the base. Okay, so the surface area for a regular pyramid. I want to kind of derive this so that it makes sense for you. Surface area. Now, for a pyramid, it only has one base, right? So its surface area is going to be one base plus the lateral area. Now, the base is going to be whatever the regular polygon's area is. But for the lateral area, these are triangles this time, so it won't be perimeter of the base times the height. It'll be 1/2, because they're triangles, it'll be 1/2 the perimeter of the base times the slant height. Now, why does that work? So think about each triangular face. Let me switch colors here. Each triangular face, the area would be 1/2 the base times the height. So 1/2 the base, and the height of the triangle is actually the slant height of the pyramid, right? The altitude of each triangular face is the slant height of the pyramid. So our area would then get multiplied by how many triangles there are. And so that's where we're going to get the 1/2, the base of each triangle times the number of triangles is just the perimeter of the base, and then multiplied by the slant height, which is L. Okay, so your formula for lateral area is 1/2 perimeter times the slant height. Now again, the reason you want to remember the 1/2 is because they're triangles, so it's not base height, it's 1/2 base height. And then the reason it's slant height is because the height of each of the lateral faces is actually not the height of the pyramid, it's the slant height of the pyramid. So again, because the lateral faces kind of come in to a vertex in these pyramids, we're talking about regular pyramids, we're going to be doing each triangle there is 1/2 the base length times the height. So the height is the slant height multiplied by how many faces there would be, which is the perimeter. Okay, so for a regular pyramid, surface area for a regular pyramid, the surface area is one base. There's only one this time because it doesn't have two bases. Plus the lateral area is 1/2 perimeter times the slant height. P is perimeter, L is slant height. Capital B is still area of the base. Okay, so for this pyramid, I drew, in addition to the 3D object there, I drew for you the base as you're looking down on it. It's kind of helpful to either redraw that or at least draw the little apothem triangle so you have something to work with. You'll know that because this is regular, when you draw in your apothem here, it's going to cut the 8 into 4 and 4. And so on this hexagon, that's 8, this is 4. You got a big angle measure is 60 degrees, which makes this 30, 60, 90. So it's a 4, 8, 4 root 3. Okay, now when we go to find the surface area, I'm going to write the same thing as before. Perimeter would be 8 times 6, which is 48 inches. The base area is going to be 1/2 apothem times perimeter because it's a regular polygon. The apothem is 4 root 3. The perimeter is 48. And that'll be, the 2 here would cancel. That'll be 96 root 3 inches squared. Okay, our slant height, I don't need the height this time, I need the slant height, is 18 inches. When we get to volume, we will need the actual height, but right now we only need the slant height. Okay, the lateral area is 1/2 perimeter times slant height. So 1/2, 48 times 18 is 432 inches squared. Okay, and then the total surface area will be one base plus the lateral area. So one base was 96 root 3. The lateral area was 432, and that'll be in inches squared. Okay, now a cone acts pretty much the same way as a pyramid, except that again it's not actually a pyramid because it doesn't have a polygon as the base. but it's still going to be a base with a lateral surface that comes up to a point at the top that's the vertex. Okay, so the surface area for a cone, let me kind of derive this for you too. For a cone, the surface area would be, move that up a little bit, the surface area would be one base plus the lateral area, just like with a pyramid. And this time the base is a circle, so it would be pi r squared plus, and I'll put in 1/2 perimeter times the slant height, just like on a pyramid there. Okay, so pi r squared plus, now the perimeter is a circle, so circumference is 2 pi r times the slant height. But now notice that this 1/2 and the 2 will cancel each other. So it's really pi r squared plus pi r l. So the pi r squared is the circle. This is the circular base. Okay, and then this part here is your lateral surface area. And remember that it's 1/2 the perimeter times the slant height, so it turns into pi r l. So surface area for a cone, surface area is pi r squared plus pi r l. Okay, the lateral area is the pi r l part. And again, L there stands for slant height. Okay, so for this cone, now I want you to notice that if we needed the height of this, which we don't, but we would if we were doing volume, when you drop this perpendicular, this is a right cone. So that height right there would be perpendicular to the base at the center of the circle. And this is a 3, 4, 5 Pythagorean triple. So if you needed the height, it would be 4. Now this is the slant height over here. It's given to be 5 meters. Okay, so for our surface area, we're going to do I think I'll just do the formula. For surface area, the lateral area first is pi r l. So it's pi times the radius of the circle is 3. The slant height is 5. So it's 15 pi meters squared. Okay, and then our total surface area will be one base, which is pi r squared, plus the lateral area, which is pi r l. Okay, so that'll be pi times 3 squared plus, I don't even really need to, I don't really need to write it that way. I'm going to write it like this. I'm going to write it like base plus lateral area, and the base is pi r squared plus 15 pi. So pi times 3 squared is 9 plus 15 pi is 24 pi meters squared. And that's your total surface area. Okay, that will be the end of this first part of the lesson. The second part of the lesson will be over volume of pyramids and cones.